5 o'clock. So welcome everybody to this course of trigonometry. As you are aware, what we've decided to do is to split the grade 12 class so that one class can move a little bit faster than the other class. This is the class that is going to move a little bit faster. That being said, I'm not planning on moving at breakneck speed. I obviously want to do things thoroughly and properly. So please do ask either Coco or myself if there are things that you don't understand or you'd like me to re-explain. And similarly, if there are things that you feel that we're doing that are a little bit too easy and you want to be challenged a little bit more, then, you can ask for those sorts of questions as well. What I've tried to do is I've tried to create a lesson where there's a lot of extra material that we may not get to. So if you do want to come back and watch the lessons again at a later stage, I'll move all the blocks out the way so that you can see what the answers are. But then you can try the questions on your own and then come back and mark it, which I think would be quite useful to you. As you know, in matric, you really do need to be very mature and very sensible about your studies. There's a lot of work that you need to do on your own. And I think if you can work through one of these videos afterwards with the extra information and see all the steps how to get to the answer, that's definitely one thing that can really, really help you. Okay, anyway, Coco, it's lovely to have you with me again. Coco is my special friend, so I'm obviously also really, really happy to see her again because I haven't seen her in a while. So big welcome to all of you. Let's get started. And the first thing that I want to ask you guys is, do you know what a compound angle is? What is it? I mean, we learn about compound angles at school and our teachers teach us them, but if somebody actually had to say to you, what is a compound angle? What are you actually learning about? What does compound mean? Anybody know? Even if you don't know, you can say you don't know. There's no judgment here. If you don't know, that's great, because I want to tell you. Do you guys know what a compound angle is? You can pop it in the chat.
Maybe you can give us a thumb, like if you have some sort of idea, you can give us a thumbs up. And if you say, oh, ma'am, I have no idea, or you can just put a thumbs down and then we can kind of get an idea of what we're going to say.
Thanks, Casey. I love it. I'm so glad you don't know. Bochepo, no smile. Lovely. What about the rest of you? Do you know what a... Excellent. You see, it's so true, isn't it? We learn about these at school, and we actually don't know what it is that we're learning about. So it's really not a difficult concept to understand, but I think understanding what it is makes it easier for you to understand what you're doing in terms of going forward. Oh, someone said something. Hang on, what's Tisha said? Yes, Tisha, there you go, quite right. So a compound angle is defined as an angle that is made from the sum of two angles or the difference of two angles. Now, that's a lot to swallow. What I'm saying is this, it's actually very simple. Here's the Cartesian plane, badly drawn by me. There's the x-axis, there's the y-axis. Remember, our terminal arm is anchored at the origin, and it swings around the origin in an anti-clockwise direction or a clockwise direction if angles are negative, okay? And let's pretend my terminal arm swings up and now it's sitting over here, all right? And what I had done is I had gone 60 degrees in this direction. Let's pretend I now go a little bit further, all right? My terminal arm is now going to come to rest over here. Let's say I went theta degrees forwards as well. Then I would say that the entire size of this angle over here would be 60 plus theta. That is a compound angle. Okay, so it's the sum of two smaller angles. It can also be the difference, right? So now if you can imagine that I could create an angle by, let's do a Cartesian plane. And again, my terminal arm is anchored at the origin and it swings about the origin. Now let's pretend my terminal arm goes all the way up here. Okay, so I go all the way up there and that was 80 degrees. Now I change direction, because remember, that's what negative angles are. I change direction and I come backwards. Let's say I come backwards alpha degrees. Now my terminal arm has stopped here. I can describe this angle over here as 80 minus, oh, sorry, it wasn't theta, it was alpha. But anyway, you get the idea. Let me just change that quickly. 80 minus alpha. Those are compound angles. Okay, matrix, so they are made of the sum of two angles, or they're made from the difference of two angles. Okay, so it's either going to be something plus something or something minus something else. The other thing that I wanted to check before we moved on is very, very important. Do you know your special angles? And do you know your co-ratios? Okay, so if you learn your special angles off by heart, it will save you time. I mean, you are supposed to learn them off by heart anyway, but if you know them off by heart, it will save you time, because then you don't have to constantly pick up your calculator to work stuff out. And then the other thing when I'm saying, talking about your co-ratios, if you know your co-ratios, what I mean is, you know that like the sine of 90 minus theta is cos theta, or that you know that the sine of 2 degrees is the same as the cos of 88 degrees. Okay, so maybe what I need to do is just go back. Are we all okay? This is this question now on the chat. Are we all okay with our special angles? I think that's something that Marilise did with you in the last lesson. Do we know our special angles? You can pop something in the chat. Yes, no, thumbs up, thumbs down. Thanks, Thelma. Cool. Thanks, Kumo. Thanks, Lorato. Please communicate with me. Thumbs up, thumbs down. Do you know your special angles?
Yeah, I'm seeing a lot of thumbs up, so I think we...
Okay. All right. Okay, that's wonderful. That is... it's going to make your life so much easier. I promise you that not 99% of trig, at least 60% of trig is studying. If you study and you learn your reduction formulae and your special angles and all that other sort of information, you really are going to get a lot further, a lot faster. Okay, and then as far as the co-ratios are concerned, those are super important in matric as well. So what I'm saying is that in terms of reduction, so if you see the sine of 90 plus theta, you know straight away that that is cos theta, for example. And the other thing that I mean is that it's like if you've got the cos of 10 degrees, you know straight away that that is the sine of 80. Or if you've got the sine of, I don't know, 1 degree, I'm being silly now, okay, you know straight away that that is the cos of 89. This is very, very, very important, okay, being able to do these as well. Okay, so if we're feeling confident about that, now we can jump into our compound angle formulae, okay? Now, these formulae are on your formula sheet. But again, if you learn them, it just means that you can work much, much faster. If you learn them, make sure you learn them off by heart and they are perfect. If you haven't learned them, make sure you copy them correctly. I have boys that I teach that we give them these formulae because you're supposed to, and they copy them down incorrectly. Okay, as far as I'm concerned, that is an absolute crime against humanity. If something's been given to you and you don't copy it correctly. So please, 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 one or the other, learn them properly or copy them correctly, one or the other. All right, so there are 4 of them, and each one consists of an angle minus another angle or an angle plus another angle. We only look at sine and cos in the CAPS syllabus. And when we first talk about compound angle formulae, we are basically just learning how to expand them. So what we see here on the left-hand side, okay, over there, is the reversal of the expansion. So when you take this and you go in that direction to produce this, it's a process known as expanding. You are expanding your compound angle. But you can also do the reverse, and hopefully we're going to get a chance to do that this lesson. So for example, if they give you this, you are then able to do the reversal of the expansion in order to do that. Okay, so that is called the reversal of the expansion. It's not called a reduction. So reversal of expansion. Now, the reversal of the expansion is a little bit more complicated than expanding, all right, because it needs to be perfect. You need to see exactly what you've got on the right-hand side. It's like a lock fitting into a key. So you can't go back to do the reversal unless what's on the right-hand side is identical to your formula. But we'll talk a little bit about that later on. In the beginning, when we're talking about compound angles, all we want to do is practice expanding them. Okay, so, and the proof of these is not something that is tested, but how they are derived are. So depending on how our course goes, I will show you how they are derived before we move on. But it just depends really on whether you guys are flying or whether you feel that this is a little bit difficult. If it's still a bit difficult, then maybe I won't, but we'll just see how it goes. All right, so in the beginning, we need to be able to recognize what we're looking at. So now that you're in matric and you see something like this that I've highlighted in yellow, you need to be able to look at that and say that is a compound angle. Okay, so it's made from x minus y. And all we have to do is then go and identify that over here. All right, so cos a minus b, it's that one. Okay, so we've got cos a minus b, cos a plus b, sine a minus b, sine a plus b. What I always tell my matric students is this to help you remember. Okay, so I'm going to write here as well. Sine keeps its sign. Okay, so as you can see, there's a minus there, there's a minus here, there's a plus there, there's a plus here. Cos doesn't keep its sign. Look, matrix. There's a minus here and a plus there, and a minus here. Sorry, a plus there and a minus here. All right, so sine keeps its sign is one way of you trying to remember, but they're a little bit different. They're not exactly the same thing. So sine compound angles are sine, cos, cos, sine, and cosine compound angles are cos, cos, sine, sine. Okay, so this is something I also teach my boys at school. I don't know if you guys are, if any of you eat this food. It is like a grain. I know I have it sometimes at night with vegetables. It's called couscous. And I always teach my boys that so that they can remember cos is cos, cos, couscous. Okay, so sine keeps its sign and couscous. And then you've just got to remember that with cosine, the angles, sorry, the sign in the middle is different. The other thing that's important to note before we start expanding is when we've got the left-hand side, that is a single term. Then when we expand at matrix, we've got two terms. Okay, very important. So if we are adding or subtracting compound angles from one another, in subtracting compound angles, we need to be careful because we're going to have a minus and we're going to have sign changes in terms. Okay, so just be aware of that. We're going from one term and we're creating something that has two terms in it. All right, so in the very beginning, we recognize cos x minus y is the same one over here that I've written all over. And all the question is asking me to do is this, expand. So I'm going to expand it using my formula. So cos x, cos y, and then remember cos doesn't keep its sign, so this is a plus, sine x, sine y. That's all I'm doing. Okay, I'm just expanding. Or if I come along and I look at this one over here, sine 2 alpha plus 45. Oh, before I carry on, is this making sense? Am I going too fast? Are you guys happy? Are there any questions? We're all fine. I really don't mind you interrupting me. If there's something that you want to ask, please pop something in the chat. I don't want to waste your time, but I also want to try and get things. Oh, cool. Thanks for all the thumbs ups. That's lovely. Okay, so you've got the idea. Now, when it comes to something like sine 2 theta plus 45, this is why I was saying to you, your special angles are so important, because 45 is a special angle. So now you look at it, you recognize that it is a compound angle because it's made of the sum of two other angles. So now we go and we have a look. We know that it's going to be, let's change color. We know that it's going to be this one over here. Okay, sine keeps its sine. Right, so now we're going to come along and we're going to expand it accordingly. So we've got sine 2 alpha cos 45. Sine keeps its sign, so this is plus. Now here we're going to write cos 2 alpha sine 45. Now we cannot leave that there, all right, because the cos of 45 and the sine of 45 are special angles. The other thing that's important to note is in this expression, sine 2 alpha is being multiplied by cos 45. And cos 2 alpha is being multiplied by sine 45. So cos 45, really, if I can write it as a number, it becomes the coefficient of sine 2 theta. Again, if you know your special angles, look how quick and easy this is. Cos 45 is root 2 over 2 sine 2 alpha. And the sine of 45 is exactly the same thing, because remember, one's cos, one's sine, they add up to 90, they're co-ratios. So this would be root 2 over 2 cos 2 alpha. Those are not like terms, so I cannot add them together. If I wanted to, I could leave it here. If I wanted to, I could take it one step further and factorize out the root 2 over 2. But if I don't do that, I'm not going to be penalized. Okay, so I could stop there. All right, but if I can use my special angles, then I am expected to do so. Okay, so now I've been talking and talking and talking. Here's a traffic light. Here is the compound angle formulae. Hopefully you can see that. What I want you to do is pick two, all right? So either try B and E, or try C and F. Okay, so C and F would be seen as sort of slightly more difficult. B and E would be a little bit easier. I've got all the answers. Let's see what you can do in 2 minutes. Okay, and then I want to talk about H as well, because that's important later on. Okay, so if there's no questions, give those a try. And if you're finished, you can pop the word done or a thumbs up into the chat. Cool, Kumo. Okay, so Kumo, if you want to, you're welcome to try H if you'd like. I'm just going to wait 1 more minute. Cool, Thelma. Cool, Pilo. All right. Okay, cool. There's quite a lot of you that have done that. All right, so let's not waste any time. There we go. All right, so there's B. So sine x cos 50 minus cos 50, sorry, cos x sine 50. C, cos 2x cos y minus sine 2x sine y. E, you should have ended up with special angles. And in F, again, you should have ended up with special angles. If you wanted to factorize out that root 2 over 2 in F, you could, but they won't penalize you for that. Everybody good? Everybody happy with that? Cool, Thelma. All right, so I just wanted to mention here, just because this is where, excellent, guys. Oh, that's beautiful. You're making my day. You really are. All right. So I just wanted to mention this here because when we talk about this, double angles come from compound angles. Okay, so that's how double angles were created or discovered. I don't know what you want to call it. Okay, so here, if we've got cos A plus A, I just wanted to show you guys this. Again, we recognize that it's a compound angle. And look here, cos A plus A could also be written as cos 2A. All right, so that's a double angle. But if we expand it here using our compound angle formulae, you can see where this comes from. Okay, so we end up with cos, so cos A, and then remember it doesn't keep its sign, minus sin A, sin A. Right, and that's where we end up getting cos squared A minus sine squared A, from which you will see, we're not going to talk about it today, but that's one of our cosine double angle expansions. All right, I'll also, when we get there, I'll explain to you where the other two come from if you want to know. But I just thought I would point that out to you. Okay, so double angles come from compound angles. Okay, let's move on. So express the following as a single trigonometric ratio. So now what they want us to do is they want us to go back the other way. So we are doing the reversal of the expansion. The most important thing, matrix, is that you have to get your expression looking like the right-hand side of one of your compound angle formulae. Otherwise, you cannot turn the key in the lock to go back and write it as a compound angle. Okay, so that's really, really important. If you have a look at it, so these first ones are super easy. I mean, if we look at this sine 2 theta cos theta plus cos 2 theta sine theta, we can see straight away that that's going to be sine A plus B. All right, you get faster. The more you practice this, the easier it becomes. All right, so I can see that that's exactly what I've got here. So now I can go back the other way. So that means that I can write this as the sine of 2 theta plus theta, which gives me sine 3 theta. Okay, and similarly, if you have a look over here, the second one, if we look at that, and we've learned these off by heart, cos, 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 sine, sine, same. There we go. This has to be a cosine. So here we would write cos, remember, cos doesn't keep its sign, so this will be minus x. And of course, there's absolutely nothing else that we can do with that because those are not like terms. All right, now, before we move on, I want to show you this one, okay? Now, something's different here. Okay, let's just bring that down. Something's different here. The number 1, number 2 was super easy, okay, because it was identical to the right-hand side of a compound formula. But this one isn't. So what are we going to do here? What do I need to change first of all? Does anybody know? Can anybody tell me what's wrong?
Co-ratios, ma'am.
You don't need co-ratios to answer this one, Emihle.
Oh, all right, ma'am.
Sorry, but it's a good guess. You will later on when we start working out the value of expressions, we will definitely, but that's not what this one is about. There we go. Okay, everybody, if you have a look in the chat, okay, look at what Casey's written there. Okay, Casey Pilani, well done, Casey. Change the cos and the sine, like switch them before taking out a minus. That's exactly it. So guys, if you have a look, can you see it starts with sine, sine instead of with cos, cos? All right, so here the cos, cos, remember each sign in algebra, each term in algebra owns the sign in front of it. So here the cos 5 theta, cos 4 theta owns this negative sign in front. So I'm doing what Casey said. I'm going to have to swap them around. Now I'm swapping them around in the same way that if I write 7 minus 3, and then Coco comes along and she says, okay, Lee, well, what about -3 + 7? These two statements are identical to one another, aren't they? I've just changed the order of the terms. That's what I'm doing. All right, so I'm writing minus cos 5 theta, cos 4 theta, plus sine 4 theta, sine 5 theta. Okay, now what I should really do here actually is I should swap these two as well. So what I'm going to do, not that it's really going to make any difference, but let me just do that. And I'm going to make that one 5 theta. Come on, pen. I'm going to make that one. Hi. What are you doing? Okay, there we go. Hopefully it's working now. There we go. 5 theta. And there we've got 4 theta. But as Casey said, this negative here, guys, is a problem. Okay, because now what's on the right-hand side, it doesn't look exactly like one of these, like that one there or that one here, because these ones don't have negatives in the front, do they? Okay, so we've got to find a way of dealing with this, right? And that's what Casey was trying to say. We're going to factorize that negative out. Okay, so next line, we're taking out the negative. We're going to use brackets because we've got two terms, all right? And the sign of the term in the middle is going to change. Okay, so we've got cos 5 theta, cos 4 theta, minus sine 5 theta, sine 4 theta. Okay, and now, guys, now this here looks identical to which one? Not to both of them, obviously. All right, but it looks identical to this one over here. Okay, can you see what's inside the bracket is identical to what I've highlighted in yellow in my compound angle formula? So that's what I mean when I say it's like a key fitting into a lock. Okay, now that it's identical to the right-hand side, now I'm allowed to go back and do the reversal. I can't do that until what's on the right is identical. The only difference here is that my angle, or my ratio, sorry, not my angle, my ratio is going to end up being negative. So this is going to be negative cos 5 theta plus 4 theta equals negative cos 9 theta. Okay. Does that make sense? Is everybody okay with that? All right, so again, here's another traffic light for you. You guys can try, I don't know, maybe you want to try one or two. I've got all the answers here as well. These ones are not that difficult, so theoretically you should be able to fly through them pretty quickly. Yeah, I'll give that a go. So we're doing the reversal of the expansion here. But Chip, what are you asking? You saying cos 30? Do you mean cos 30 minus 10 is cos 20?
Cos 3 theta.
It's
minus theta.
Yeah. So it's theta. It's 3 theta and well, cos 3 theta, cos theta. Okay, it's very easy to get confused between 30 and 20 and theta. You got to look so carefully. But these are all angles in terms of a letter. They're not actually numbers. Are we done, guys? Can we move on? Done. Okay, Thelma. Sorry, I'm not trying to rush you. Casey, cool. Awesome. Okay. So there we go. Those were my answers. I hope I got everything right. So for A, cos 2 theta, for C, sine 2p, and for E, sine 2x. Okay. All right. Now, this is where things start to get interesting. Okay. This is what I've been trying to get to in our lesson. All right. Very big part of matric, they ask us to now start doing calculations without the use of a calculator. Did you see, by the way, at the top over here, I said no calculators, and I'm going to say that in every single lesson. Okay, there are no calculators until we get to trig equations. All right. Obviously, if you do use your calculator to work out like something for Pythagoras or something like that, then it's okay. But if you just pick up your calculator and write down the answer to that, you're not even going to get a mark for the answer. All right, so they want to see that you've understood the concept and that you're able to apply it, not that you can press buttons on a calculator. So this is the hard part. You need to look at this and you need to recognize it for what it is. Cos 320 times cos 20 minus sine 140 times sine 200. What we're supposed to be able to do now, matrix, is recognize that, let's just grab this goodie and bring him down here, that is a compound angle. Can you see the cos in number one? Cos, cos, and then sine. All right, so we're supposed to be able to recognize that is a compound angle. All right, so before we get started, what we notice, and I chose this on purpose, is that these angles here, this one here, and that one there, none of those are acute. So rule number one, okay, always reduce using your grade 11 reduction formulae. This is why they're so important, okay? And you have to write what you get as a result of reducing, okay? So what I mean is this, in number one, okay, cos 320 is quadrant number 4. Okay, so we would use 360 minus. We don't have to write that. 360 minus, that would leave us with the positive cos of 40 degrees. That's what you have to write. Okay, you don't have to write 360 minus 40 and then cos 40. Times cos 20. Now here, minus sine 140. That's in quadrant number 2. Okay, where sine is positive. So this is going to reduce to positive sine 40. All right, times sine 200. Now 200 is in quadrant number 3. Okay, quadrant 3, where sine is negative. Okay, so this reduces to, careful now, negative sine 20. Okay, so we have to reduce first. Now we want to take care of these signs here. When I say signs, I mean S-I-G-N-S. But this second term, I can't write it as minus a positive times a negative. So the next thing that I want to do is take care of the fact that a negative times a negative is going to leave me with a positive. My next step, cos 40 times cos 20 plus, because a negative times a negative is a positive, sine 40 sine 20. Now I can look at it. Cos 40, cos 20, sine 40, sine 20. Yep, it looks like this over here, doesn't it? Okay, it's that one. So now that I've got it identical to the right-hand side, now I can go back the other way. So now I'm going to go cos. Remember, cos doesn't keep its sign. So here I would end up with 40 minus 20, which leaves me with, have I made a mistake?
I don't think so, ma'am, but a few people are asking, where did we get the 20 and where did we get the negative sign?
Okay, all right, so let me just go back. Okay, so cos 320, so it would be 40 to get to 360, wouldn't it? Yes.
Yes, ma'am.
Okay, and then we've got cos 20, which didn't change. And then sine 140, that would be 180 minus 40. So that would be sine 40. And then sine 200, that would be quadrant 3. That would be 180 plus 20. So that's why it would be negative sine 20.
Ma'am, is there any chance we can draw the cast diagram quickly? And
yes, 100%. Not a problem. Not a problem. Okay, so let me just see where I can stick it. Okay, so here C-A-S-T. All right, so this quadrant over here is 360 minus. This one is 180 plus. This one is 180 minus. Okay, so that's why we would have the sine 40 and then the negative sine 20. Does that make sense to everybody? Are we okay, Matrix? Okay, so everybody's saying, yes, yes, we seem to be fine. Okay, the only thing that I don't understand what I've done here is it did say to us evaluate, which means that we should have been able to get it. So normally what happens is that these come down to a special angle, and then we're able to use special angles in order to rewrite them as the value of something. Let me just double check that I didn't do something silly here.
Lee, can I just explain something?
Yes, with pleasure.
I think Casey may have been a bit confused. She's asking, why do we use 180 and not 270? But I think I've just explained to her in the chat. For those of you guys who didn't see, using things like 90 plus and 270 minus, that's something we don't really do in school. It is possible, but it gets very complicated. So we always reduce the angles from the x-axis, always from the horizontal. And the horizontal will always be 180 minus 180 plus, or 360 minus, and everything 360 plus will just be 0 plus. So it will give us that original angle. So we always look at it from that x-axis, which is 180, and then we reduce either towards 270 or towards 90, depending on which one you're looking at. Okay.
What actually happened here, guys, is that this was actually a typo in the textbook. Sorry, now that I'm looking back, I can see that that was actually supposed to be a plus, because it doesn't make sense if it's actually not. So if it's a plus, then it makes more sense to us. Hold on a second, let's just change these signs, because then that would be a plus, and then a positive times a negative would end up being a negative, which is what we want in the middle over here. We want a negative over there, so that that's plus, so that this becomes the cos of 60, and then the cos of 60 is the same as the sine of 30, which would be 1/2. Sorry, trust me to go and pick the one question out of the textbook that has a little typo in it. All right. Does that make sense to everybody? Okay, so remember, we can never ever forget about the cast diagram. Okay, so we're using our reduction formulae in order to be able to do this. Let's do another one. Okay, so in number 2, I've actually worked out the answers already, but in number 2 again, okay, cos 10 sine 160 minus sine 10 times sine 110. Can you see the sine 160 and the sine 110? Those angles are greater than 90. All right, so that means that we first need to reduce this, and we need to reduce that. Always do your reductions first. Okay, now Matrix, you try and write that first line where you've reduced. So you're going to write your cos 10, and then write your sine ratio reduced, then write your minus sine 10, and then write sine 110 reduced. And let's see if you've got the same thing as me. Cool, Kumo, give the answer. Do you want me to reveal mine or do you want to give the answer? -1/2, Kumo says. Let's see, Kumo. That's what I got. Unless I made a mistake, Kumo. Okay, so I've got cos 10 sine 20 minus sine 10. Now you see here, Kumo, what the problem was, and all the other matrix as well, is you've got cos sine, sine sine. Okay, so cos sine, sine sine is not a compound angle formula. All right, so it either has to be sine cos, cos sine, or it has to be cos cos, sine sine. So this is one where I used a co-ratio in order to be able to get to my answer. Should I perhaps do number 2 again to explain to you what I've done? Because really, I think what needs explaining is this over here. The rest of it makes sense, I'm sure. Or maybe I can just explain that on the side. Okay, all right, no problem. So guys, when we reduce sine 110, I'm just going to do this on the side here, sine 110. That's quadrant 2, it's 180 minus. So this reduces to positive sine 70. Now here we've got a 10 and a 20, and here we've got a 10. So to have a 70 would be out of place. But I know from my co-ratios, this is why you got to know your co-ratios so well. Okay, that's 20 and 70 add up to 90. So that means, matrix, that I can rewrite the sine of 70 as the cos of 20. Does that make sense to everybody? And that is what I've got over here. What do we think now? Does that make sense?
Lee, I think we agree with you.
Okay.
That does make sense. I think the second line is where we're having a bit of a, well, where I'm having a bit of a problem.
Okay, so then maybe I made a mistake there. Just hold on. Kumo says, oh, can you explain again?
So I'm just
okay, maybe I was right. Okay, was I writing nonsense here? I could very well have been. Hang on a second.
Because I see cos sine and sine cos, and if I
and that would be sine, wouldn't it? Not cos.
Should have been
quite
sine.
right.
Yes.
Sorry.
Yeah.
Okay, so we've got cos sine, sine cos. So this one over here is going to be this, isn't it? Okay, so sine 20. So this is the same as writing sine 20 cos 10 minus cos 20 sine 10. Okay, so I can change the order of the cos 10 and the sine 20. That's okay, all right, because A times B is B times A. Now that I've got it looking identical to the right-hand side of the compound angle formula, I can go back the other way. So now what I would end up doing here is sine 20. Sine keeps its sign, doesn't it? So here it would be sine 20 minus 10, which would leave me with the sine of 10. Okay, and I cannot evaluate that any further than I have. I mean, I know it says calculate the value, but you can't use your calculator or go any further. Does that make sense, Matrix?
Lucona's just asking if you could explain number 1 again.
Sure. Okay, let me go back and explain number 1 again. Okay, first of all, what made number 1 a little bit confusing, sorry, is I picked a question out of the textbook where there was a typo. So this over here is supposed to be a plus in the middle. It's not supposed to be a minus. All right, so that's the first thing. So as it sits there right now, it's correct. So let's do it again. All right, cos 320 is quadrant 4. So I'm going to use the reduction formula, 360 minus. So this reduces to positive cos 40. Cos 20, I don't have to reduce, it is reduced. plus sine 140, that's quadrant number 2. I'm going to use 180 minus. So 180 minus 40 gives me 140. So this reduces to sine 40. And then here, sine 200, that's quadrant 3. I make 200 from 180 plus 20. So this will reduce to negative sine 20 because sine is negative in quadrant 3. So what I've got is I've got cos 40 times cos 20 plus sine 40 times negative sine 20. So now I need to take care of my signs. So in other words, my plus and minus signs. This gives me cos 40, cos 20 that are both positive. And now I'm multiplying a positive term with a negative one. So a positive times a negative is a negative. And this gives me sine 40, sine 20. Now I can see that I've got my cos, my cos. Right, 40 here, 40 there, 20 here, 20 there. So it looks identical to my compound angle formula. It looks identical to this one over here that I'm highlighting in yellow. So now I can do the reversal of the expansion and go back the other way. So I'm going to rewrite this as the cos of 40 plus 20. See, I'm doing this now. And that gives me the cos of 60. And the cos of 60 is the same as the sine of 30. So special angle, the answer is 1/2. Okay. And then someone's also asked, ma'am, on the right-hand side, Pilo, where do you see negative cos 20? There's no negative cos 20
I think
in this
you
question.
meant in question 2.
Oh, do you think you mean that she means over here?
Get it up.
Okay. All right. So Pilo, what I've done here is, remember, if you've got AB minus CD, if I write this as BA minus DC, have I changed the meaning of what I've written? No. So these two are being times together. A and B are being times together, and C and D are being times together. So if I swap them, there's nothing wrong with me doing that. So all I've done here is I've brought the sine 20 to the front times the cos 10, which was here in the front. So I've swapped those two factors. Then in the second term, I've also swapped the factors. I've swapped cos 20 and sine 10. Does that make sense now? Because remember, I wanted to look identical to this. That's why I did it. Okay, so that I can do the reversal of the expansion. Okay, all right, Pilo. All right, so that's why I was sort of trying to stress in the beginning. Remember, what you are working with here, you're going to create two terms. That each term is made up of something times something. And remember, in maths, the order in which we multiply those two together does not matter. Okay. All right. How are we feeling now? Does this make a little bit more sense to everybody? Sorry, these were a little bit difficult. It would have helped if I hadn't made a typo there, but I know that now. You are allowed to work with angles that are bigger than 45. So in other words, you could get 60 or you could get 90. So any special angle, so you could get that as well. All right, so here's one for you guys to try before we go away. All right, I hope I did my answers correctly. I didn't make any mistakes. Okay, so we've got A, C, and E. A is the easiest, C is medium, and E would be the most difficult. Right. Again, you are going to be using your compound angles. Let me just grab them and drag them down here again in order to be able to answer these questions. So I'm going to give you, Coco and I are going to give you an opportunity now to do one of these. You can either do the easy, or you can do the medium, or you can do the hard. Okay, so give that a try. And of course, if you get stuck, then ask us. Okay, so this is easy, this is medium, and if anybody wants a challenge, then E is the most difficult. Okay, Bochepo, we'll mark it out. Try the second one if you want to, Bochepo. And let's see how it goes. Quite right, Tisha. Okay, so this is where we've got to be so careful with whether we are adding or whether we are subtracting. Correct, Tisha. Okay, Bochepo, you just need to be careful. Okay, you minused instead of added. Okay, remember, you've got to look so carefully at your formulae to make sure that you're doing the right thing. Good, Tisha, that's great. Anyone trying question C or E? I'll move A out the way. All right, because I quite agree. That's what I got. Okay, cool. All right. Cool, Pilo. Nice, Jamie. Good job. Okay, you let us know when you're done and I can reveal the answers. Okay, Kumo, no problem. Right, E is a difficult one. All right, so Kumo, let's talk about question E and then I can come back to question C. If you're busy with question C and you want to finish it off, that's fine. We don't have a lot of time left. We're always rushing against the time, aren't we? It's such a... Okay, so Pilo, you say you got sine 90. Okay, let's see what I got. Let me delete this. I got the cos of 0, which is 1. But the sine of 90 No, the sine of 90 would be 0, wouldn't it? Okay, unless I made a mistake, but hopefully I didn't. But Peter, let's just double check this. All right, so our question was, Coco, check me as well.
No, I also thought I was going crazy, but I also got cos of 0 degrees.
Did you also get cos 0? Okay, all right, no, that's
Cos
fine.
0.
Okay, so this is what I did. I said cos 65, cos 295 minus sine 115, cos 205. I then reduced cos 295, which is quadrant 4, to cos 65. Okay, so this one over here reduced to that one over there. We're working in quadrant 4, so cos is positive. Then sine 115 is quadrant 2. So that is going to reduce to sine 65. And then cos 205 is quadrant 3 Pilo. This is quadrant 3. So that means that cos is going to be negative. So the first thing that I always do here is I always take care of my signs. A negative times a negative is a positive. So now I've got cos 65 plus sine 65 sine 65. So that gives me cos 65 minus 65, which is the cos of 0, which is 1. Okay. So I don't think I made any mistakes there. Have you found your mistake, Pilo? Do you know where you went wrong? C, you said a sine. Okay, Pilo, that's great. Okay, Boitshepo, let's go back to question C for you. Let me get rid of that. I got sine 60. Okay, so again, let's just explain this one quickly before our time is up. Just make sure I wrote it down correctly. Okay, so sine 280. All right, Boitshepo, that is quadrant 3. Oh gosh, that's not what I wanted to do. That's quadrant 3. Okay, so that's why it's going to reduce to negative sine 80. Cos 160 is quadrant 2. So that's also going to reduce to a negative ratio, negative cos 20. Okay, then I brought down the minus there, put the minus over here. Cos 100, that's also quadrant 2. So that's also going to reduce to a negative ratio. I got negative cos 80. And then sine 200, that's also going to reduce to a negative because 200 is quadrant number 3. So that's why I got that. How did you change the cos 25 to sine 65? Because of co-ratios. So you're still talking about the other question. All right, because this is what I'm saying, you've got to know your cos ratios so well. Remember, the cos of 25 is equal to the sine of 65. They're co-ratios. So if these two numbers add up to 90, one is sine, one is cos, then they're equal to one another. Very, very important. Okay, you've got to be able to do that. Okay, so now I said a negative times a negative is a positive. So here's a positive. And then here I said a negative times a negative is a positive. And when you add a positive, you are subtracting. That's why I've got a negative over there. So it's sine cos, cos sine. That's a cosine, sorry, that is a sine compound angle. Sine keeps its sign. So sine 80 minus 20 leaves us with sine 60. And that is root 3 over 2. Okay. Are there any other questions? Yes, so right, sine 1a, sine 60, root 3 over 2. Correct, Tisha. Correct. Okay, good job. Okay, so just very quickly, if you do want to watch this video again later, there is another question that I was going to do with you. Something like that is also important. Then I had done these, so I'm just going to move that out the way, how you would prove that the left-hand side equals the right-hand side. So if you want to come back later on and come and watch these, you can. There's that solution over there. These are important, especially later on when we start doing solutions. two identities. And then the other thing that we were supposed to do this lesson as well was calculate like the sine of 75 using a calculator. So if you want to try those questions there, these are also made from compound angles, then we can do so. All right, so I just wanted to show that in the video so that you were able to come back to these if you wanted. Are there any last questions, Matrax? Oh, and I've taken up a lot of time this lesson because you still got a quiz that you guys need to go and do. Coco, are you popping the quiz, the link to the quiz into the group for everybody?
I am doing that right now.
Oh, you are an angel. Okay, guys, I hope that you enjoyed your lesson. If you want me to slow down, speed up, more easier questions, more difficult questions, please give us your feedback. I've got to try and make these lessons right for you, but go and try the quiz now. And then we'll see you all again next week on Tuesday, and we will continue with double angles. I hope you enjoyed this lesson. Bye, everyone.